Bismillahirrahmanirrahim. Welcome to section 3.5, shared memory. So for this section, we should start with the next slide. Okay. So here we have shared memory. So the definition of this cooperating process, okay, is an area of memory being shared among the processes that wish to communicate. The communication is under the control of the user's processes itself, not the operating system. For shared memory, operating system not allow a process to interfere or to interfere another process memory. Okay, so for shared memory, to allow to allow the interaction process, okay, among them, so they have to release the restrictions. Okay. So we have to continue with the previous slide. Okay, so for in shared memory, we have a producer and consumer problem. So actually this is a paradigm to illustrate the concept of shared memory. So producer process produce information that is consumed by a consumer process. So for example, we have a compiler to translate our source code into assembly code. So compiler will produce assembly code that will be consumed by assembler. The assembler will produce a relocatable object file that will be consumed by a linker. So we can see there is a process that will act as producer. Okay, then there will be a consumer process that will consume the information that has been produced by the producer process. Okay. So in shared memory, we have two types of buffer, unbounded and bounded. For unbounded, it has no limit on the size of the buffer. Okay, so producer process are free to produce the new item. Okay, while in bounded buffer, okay, there is a fixed buffer size. Okay, so if the producer process has reached the maximum size of buffer, it needs to be weighed. Okay, while for consumer process, if the buffer is still empty, it has to be weighed until the producer process produce informations. Yeah. Okay, we continue with this slide. Okay, so in shared memory, they have to provide a mechanism that will allow the user processes to synchronize their action when they access shared memory. So why they have to synchronize their actions? Because we don't allow a consumer process to consume any information that has not yet produced by the producer process. Okay. So synchronization will be discussed in chapter 6 and 5. In chapter 6 and 7. Okay. Now we look how we can create bounded buffer for shared memory. So this is the declaration for bounded buffer. So first we define the buffer size. Okay, as the size is 10. Then we have a user defined data type item here. Then we declare two pointers. Okay, the in pointers will point to the next free position in the buffer, while out pointer will point to the first full position in the buffer. Okay, right. So for the producer process, okay, we declare next produce variable. Okay, so this is to store a new item. Okay. Okay, so the producer process, it will repeat the process. Okay, as long as it not reach the maximum size of the buffer. Okay. Okay, we will assign the new item to be stored in the first buffer. Okay, and then we increase the buffer size. Okay, so that it can produce it can start new item for on the next buffer. Okay, in the next on the next buffer. Okay, so it will keep repeating the process until the buffer is full. Okay, for the consumer process, okay, first we declare the next consume variable to store the information produced by the producer. Okay, then the process will repeat until the buffer is emptied by the consumer. Okay, so first we assign the item in the first buffer, okay, to be stored in the in next consume variable. Okay, then we increase the buffer size so that it will consumer will empty the next item. Okay, so the process will keep repeating until the buffer has been emptied. So that is how shared memory process. Okay, we will discuss shared memory in the next chapter because thread will share the memory by default. Okay, right. Thanks for watching.